Which of the following would be terminating decimals and which would recur? Now remember, we're looking in the denominator for any primes that are not just 2s or 5s, and those ones will recur. So if we look at 3/4, well, 4 is 2 times 2. So there's no reason that that would be recurring. That one's terminating. But if we look at the 6 here, that is 2 times 3. So I have a prime that isn't a 2 or a 5. That's going to recur. And straight away here, we can see 30 would involve 3. I know I haven't reduced the 10 to primes, but I don't have to. I just need to find a prime that isn't 2 or 5. With 25, that's 5 times 5, so that one would terminate. Write 0.27 as a simplified fraction. Well, from all the work we've done, we know that's 27 over 99. The recurrence pattern is 2 digits, so we could use 2 9s. But 27 and 99 both divide by 9. So that is going to be 3 over 11. You could divide it by 3 and then by 3 again, but it does say a simplified fraction, so you must get down to 3/11ths. Write 215 over 999 as a recurring decimal. The 999 tells us the recurrence pattern is 2 digits long, so it's going to be 0.215 recurring. Write 0.34 as a simplified fraction. Now this one's not recurring, so that 34 is over 100. And that gives us 17 over 50. As a percentage, we can see from here, because percentage means out of 100, that that's 34%. Which of the following are rational and which are irrational numbers? Well, 3/4 is a fraction, so that's definitely rational. The square root of 5 is the square root of a number which is not a perfect square. Those are irrationals. They're known as surds. 0.1432, that's a recurring decimal. So we could express that as a fraction, and therefore it is rational. Pi is an irrational number, and it's not going to change anything if we take its square root. So that is irrational.